Jars of pickled hard-boiled eggs follow a normal model, weighing 5 pounds with a standard deviation of 0.4 pounds. The jar always has 20 eggs in it. If the jar in vinegar weighs 3 pounds with a standard deviation of 0.3 pounds, before the eggs are added, what does it mean in standard deviation of 1 egg? So let's write what we're given. We're given that the mean weight of the jar with vinegar is 3 pounds. The standard deviation of the jar with vinegar is 0.3 pounds. The total weight of the jar with vinegar and 20 eggs is 5 pounds. The standard deviation of the total weight, that is the jar plus vinegar plus eggs, is equal to 0.4 pounds. So let's first calculate the mean of 20 eggs. So for the eggs, it's going to be the total meaning the eggs plus the jar in the vinegar, minus the mean of the jar in the vinegar. So for us, the total is 5, minus the jar is 3, so that's going to be a total of 2 pounds for the 20 eggs. And to calculate the mean weight of 1 egg, we have to take the 2 pounds divided by the 20 eggs, because this is for 20 eggs, and that's going to be 0.1 pounds. Okay, so that's the mean of 1 egg. Now we want to calculate the standard deviation of the weight of 20 eggs. So the standard deviation squared of the total is a standard deviation squared of the jar plus the standard deviation squared of the 20 eggs. So now we just plug in what we're given. We know that the total is 0.4, so we're going to square that. We know the jar is 0.3, square that, and then we have to square the standard deviation of the 20 eggs. So 0.4 squared becomes 0.16, and then we'll subtract the 0.3 squared, which is 0.09, equals standard deviation squared for the 20 eggs. So that'd be 0.07. And so to get just the 20 eggs, you have to take the square root of both sides. And that's about 0.2646 pounds. To get 1 egg, we need to take the standard deviation of the 20 eggs and divide it by 20. And that's going to be about 0.0592 pounds. So to summarize, the mean of 1 egg is 0.1 pounds. The standard deviation for 1 egg is 0.0592 pounds. And that is our final answer.